compounds in aqueous solutions. So dissociation means that you can separate the compounds into ions. A precipitation reaction, remember precipitate means a solid. So it's when we have a solid formed on the product side. So you have to be looking at your solubility rules. And we look at the second thing in the formula, iodine. All iodides are soluble except with silver, lead, and mercury. So this is going to remain aqueous, which means when we put potassium iodide in water, because it's aqueous, it will break into the ions, potassium plus 1 and iodine minus 1. Lead sulfate. So if I look at the rules for sulfates, all sulfates are soluble except calcium, strontium, barium, mercury, lead 2, and silver. So I'm with an exception. So it's no longer soluble, but a solid. So when I put lead sulfate into water, it doesn't do anything. It remains together as lead sulfate. So net ionic equations. You have to use ions instead of formulas if it's not a solid or liquid. You have to dissociate your ions and show the precipitant. And then you're going to cancel out the spectators. So these are double replacement reactions, so we can follow along with the pattern AB plus CD goes to AD plus CB. Well, A in this problem is copper. Copper has a charge of 2 because it's been crossed here. So this subscript 2 is the charge on the copper. And then D is phosphate. Phosphate's a polyatomic, so we'll put it in parentheses, minus 3 on the outside. Cross your charges, and we get Cu3, PO4, 2. C in the problem is ammonia, so NH4 polyatomic, so in parentheses plus 1. And then B is chlorine. Chlorine has a charge of minus 1. So when I cross my charges, I have NH4Cl. Then I would need to balance. I like to balance using the polyatomics first. So I have 1 PO4, 2 PO4s. So I'm going to multiply by 2. 6 NH4s, 1 NH4, so I'll multiply by 6. Now I can look at my copper and chlorine. I have 3 coppers, 1 copper, so I multiply by 3. That gives me 6 chlorines and 6 chlorines, so we're balanced. Now I look at my solubility rules for chlorine. All chlorides are soluble except silver, lead, or mercury, so this is going to remain soluble or aqueous. Over here, all chlorines are soluble except silver, lead, or mercury, so this also remains aqueous. Then I'm going to look at my phosphates. All phosphates are insoluble except with group 1 and ammonium. So here I'm with ammonium, so this is now aqueous. Over here I'm not with an exception, so this is going to remain my solid. So my precipitant is copper phosphate, copper 2 phosphate. So I'm going to take all of my things that are aqueous and break them up into the ions. So I have 3 copper plus 2 and 6 Cl minus plus, again, break up your aqueous, 2 NH4s, I'm sorry, that's 6 NH4s plus 1 and 2 PO4 minus 3. That's going to turn into my solid. Now you can't break apart a solid, so you just copy that down. 6 NH4 plus and 6 Cl minus. So what do I have on both sides that are identical? I have 6 Cl minuses and 6 NH4s. So my net ionic equation is 3 Cu plus 2 plus 2 PO4 minus 3, giving me Cu3 PO4 2 solid. My spectators, or the ions that don't do anything but watch the reaction, are the things that I canceled out. NH4 plus and Cl minus. So let's try that again. We have AgNO3, so AB plus CD goes to AD plus CB. So A in this problem is silver. Silver is always +1. D in the problem is iodine. Iodine is -1, so that's AgI. C in the problem is potassium, +1. And B is nitrate, the polyatomic, -1. Well, this happens to be balanced because everybody had a charge of 1. So then I look at my solubility rules. Nitrates, and my rule says all nitrates are aqueous, and the word exception is not written there. So this is aqueous and aqueous. All iodides are aqueous except silver, lead, or mercury. So this first one is going to be aqueous, but the second one, being with my silver, is going to be my solid. So I'm going to break apart into ions anything that is aqueous. So I have silver +1 and NO3 -1. K +1, I -1. That's going to form my solid, AgI, K +1, and NO3 -1. So I can cancel out I can cancel out nitrate and potassium. So my net ionic equation, or net ionic reaction, is Ag plus I minus going to AgI solid. The spectator ions would be K plus and NO3 minus. Ionization is the creation of ions. So when you put stuff in water, it creates those ions. Strong versus weak electrolytes. Remember, strong electrolytes, or electrolytes, are anything that breaks into ions. So strong electrolytes are anything that is ionic, positive and negative, metal and nonmetal. And then strong acids. Now you have to know your 6 strong acids, so there's 6 of them. HCl, HBr, HI, HNO3, H2SO4, and HClO3. The strong bases are anything that end in hydroxide or OH. Now, weak electrolytes are still things that conduct electricity, but not as well. So weak electrolytes are weak acids, which is anything that's not a strong acid. So if it starts with H and it's not one of those 6, then it's a weak acid. Weak bases, or the weak base that you have to know, is NH3. So what's the difference between strong and weak? Strong electrolytes dissociate completely. So 100% of the time, it breaks into ions. Where my weak electrolyte doesn't break into ions 100%. So it's only ionized partially. Or it somewhat breaks into ions. Sometimes breaks into ions. A neutralization reaction is when you take your acid and your base and you put it together. So this is the second type of double replacement reactions. So we have AB plus CD, and that's going to turn into AD plus CB. So A is barium, Ba plus 2, and chlorine, Cl minus 1. So I would have BaCl2 plus hydrogen plus hydroxide, HOH or H2O. So BaCl2 would be what we would call the salt, and then we have our water. We would need to balance this. 2 Cl's, 1 Cl, we'll put a 2 there. That gives me 4 hydrogens, so 2 there, and we're balanced. For the net ionic, hydroxides are insoluble except with group 1, strontium, barium, and ammonia, so this is going to be aqueous. All chlorides are aqueous except silver, lead, or mercury, so this is aqueous. All chlorides are soluble except silver, lead, or mercury, so this is aqueous. And then water is always a liquid. So anything that is aqueous, you can break up. Ba plus 2 hydroxides, 2 hydrogens, 2 chlorines. Remember, these are ions, so you have to show the charge. Ba plus 2 Cl minus, and then 2 water. Water does not break apart because it's a liquid. So what are my spectators? What is identical on both sides? Ba plus 2 and Cl minus. So my net ionic reaction would be 2 OH minus plus 2 H plus goes to 2 H2O. Now notice that the coefficients are all 2. So I can actually reduce my coefficients and just change it into OH minus plus H plus yields H2O. My spectators, or the things that I've deleted, would be barium plus 2 and chlorine minus 1. AB plus CD is going to go to AD plus CB. So HNO3 plus NaOH is going to turn into H2O, because hydrogen and hydroxide form water, and NaNO3. They both have a charge of 1. All nitrates are aqueous, no matter what they're with. Hydroxide is insoluble except with group 1, so this is aqueous, and water is always a liquid. So if I was to break up my ions, H plus, NO3 minus, Na plus, OH minus, water stays together because it's a liquid, Na plus, NO3 minus. Cancel out what's identical, NO3 minus and Na plus. That leaves me with H plus OH minus yields water as my net ionic reaction. Well, if you notice from these two examples, all neutralization reactions have the same net ionic, hydrogen plus hydroxide giving you water. The spectator ions here then, the things I was able to cancel out, would be sodium and nitrate.